Preparing to solve this problem is going to mean drawing a picture. We really need to kind of like figure out what's happening here. Okay, here's the setup. I got the surface of some water here, and there's someone in a boat. Okay, here's someone in a boat. Okay, and there's also someone underneath the water. Now let's start with the diver. Okay, the diver sees the sun 50 degrees above the horizontal. What that means is this: rays of light from the sun, when they come toward the diver, come in at an angle 50 degrees above the horizontal. Okay, that's what that's telling us. The question asks this: how high is the sun above the horizon to a fisherman in a boat? Okay, now if we trace this ray of light back, this came from the sun. It went from the air into water. Water has an index of refraction of 1.33. Air has an index of refraction of 1. Okay, let's let this be medium 2. Okay, this is going to be medium 1. And as it goes from a lower index to a higher index, it's going to bend to a greater angle away from the normal. And so that tells us that the ray of light comes in at a shallower angle here. Okay? So we know the person in the boat is going to see the rays of light coming in at an angle that is closer to the horizontal. And this is the angle that we're looking for. The rays of light are coming in at a certain angle. They're coming from the sun. And so if the person is saying, how high above the horizon does the sun appear to be, this is the angle that we're looking for. And let's just call that theta F. That's the angle that the fisherman sees the sun above the horizon. That's the angle that he sees the rays of light coming in at. Now let's do some trigonometry. This angle is a 50-degree angle. So that means that this angle is a 50-degree angle. Okay, and if this angle is a 50-degree angle, that tells us this is a 40-degree angle. Now thinking about this as a refraction problem, I'm going from medium 1 to medium 2, this angle is theta 2, okay? And if I know theta 2, I can use Snell's law to figure out what theta 1 is. If I know what theta 1 is, I can figure out what the angle with respect to the fisherman is, okay? So that's going to be our sequence. And to solve this, we'll just use our basic relationship, n times the sine of theta 1. I'm sorry, n1 times the sine of theta 1 is equal to n2 times the sine of theta 2. That's our basic Snell's law relationship. And with this in place, we're ready to solve. And the solution is actually quite straightforward. We'll just rearrange our equation so it looks like this. Sine of theta 1 is equal to n2 over n1 times the sine of theta 2. Well, in this relationship, I know everything, basically. I know what n1 is. n1 is medium 1. That's air, so it's 1. n2 is water, index of refraction of 1.33. And theta 2 is 40 degrees. So we have everything we need, and so we can solve for what theta 1 is. If we do that to two significant figures, I get 59 degrees. But we're not done, because the problem didn't ask us for theta 1. It asked us for what angle was the sun above the horizon from the fisherman's point of view. So the answer we're looking for is 90 degrees minus theta 1. These two angles are complements, and so what we get is an angle of 31 degrees. Here's our assessment. In our picture, we drew that the angle of the sun from the fisherman's point of view should be shallower than the angle of the sun from the diver's point of view. And in fact, that matches our calculation.